This is the man who invited me to his beautiful shop, and at the rear of it you see Bridgeport, then the famous Monarch, the best made in US. Not probably.
That's another company went out of business.
And a surface grinder. Brownish names, all of everything. And then you have a small one, which is a micro. It's Gordon. Gordon makes coil winders. Oh, this one you use for the smaller end mills, right?
I use those for my boring bars.
And here's the Bridgeport. I was thinking about Bridgeport, but it seemed to be too heavy. I have a CNC.
Oh, you do?
Variable frequency drive is Hitachi. What is the name?
I have an SJ200.
SJ200, okay.
Yeah, actually, the covers are up. Normally, you don't even do those belts.
But this is not only one, this is only the DC. And now,
This is what I love.
RPM. Oil.
Right, that one there, each of the ends takes spindle. This is the number 6 oil.
Number
there.
6, and this is the fill.
Yeah.
This is number 10.
10.
And
The fillers all the way on the top. These are chrome.
And then we have this one, that's number 1, and this
That
window
takes
is the, how do you call it?
Vector is fine. I knew that you were an English first language guy, and I actually was guessing that you were German. I used to work for Mercedes-Benz when I first started, over in Montvale, and so we got a lot of Germans, and so I was very used to their way of speaking English. Your machine, I don't know if it has it.
Yes.
There's a switch here. Now that locks the spindle.
Yes, it is.
But mine has an electric switch as well, so you can't try to run it. But yours is.
I know. Well, I have to physically press it.
No, mine's manual too. But if you depress mine, it electrically prevents the machine.
I see what you're saying. You don't have this one.
You don't have the knob, or you don't have the cover?
No, it doesn't even have a hole. It's just.
Oh, yours bolts on.
Yeah.
Yours is probably set up for a collet chuck.
But I don't have a collet.
No collets. Do you have the tube?
I have a tube, and I have a nose.
All right, now this lathe has a bunch of things here on the apron, okay? So it has power feed. This knob here, power feed. If you go power feed, when you pull the knob out, it goes this way, okay? And that comes out. So left and out with the knob out. With the knob in, then it goes in, and it goes that way.
Mm-hmm.
One of the interesting things you can do with the lathe is you put in the center. Now you use the center position when you're threading, but in the center position, you put both controls down. So when you want to chamfer and end a piece of stock, you just turn this. As you turn this, the feed goes in, cuts a perfect 60-degree angle on the end of the stock. Handy. To deal with power feed, it happens too quickly. Then for threading, we have to do something else. First, this is the lock for the bed. That's the bed lock right there. So it keeps the apron from moving.
Right.
This is the threading lever, the apron from moving. Right. Threading dial. Have you ever cut threads?
Yes, I did.
Yeah. Now, over here is, on the gearbox, You pull up this lever and push it down, and that enables you to turn the knob. But it's
Yeah.
never done this.
Okay.
All right, let's see what I did. Oh, there it is. I must have had this out of position. It's 180
Okay.
degrees. So that only you normally leave that in right-hand thread all the time. In neutral, nothing happens. It electrically is disabled. Left hand, it reverses.
Okay.
So unless you're using threading, like when you cut metric threads on a English machine, you have to leave the thread screw engaged all the time. So you always have to use the thread reverse. Otherwise, you can't do it. So the other thing for threads, there's an interlock between this, and this. When you're going to do threads, you have to move this lever first to threads. Then you move this one from belt drive to gear drive, and then you move this one.
This switch,
Yeah.
what is that for?
That's for adjusting the dogs here to kick out that's a fine adjustment, you might say, for these. So that adjusts the position. First you get it approximate, and then you zero it in where you want the spindle to stop when using the thread screw reverse.
The position that you said is neutral in here.
There's a line.
Yeah, there's a line. Okay, right. So now the motor is not working at all.
Right.
When you put the left hand, you're making the left.
Everything's going to work backwards.
Right.
So the spindle goes backwards in left hand.
You have to stop it in order to change it. While it's
So, again, it's left hand thread, right hand thread is the reason you do that.
right.
And the reason they have that is because these ramps only are cut on one direction. So, because the ramps would only kick this thing out doing, you might say, right hand speed control is over
Yeah.
here on this.
Yeah.
Yes. Yeah, that's the gearbox. Yeah, of course.
This is the only where you.
That's the speed. Now,
Yeah, that's
so
the
what you do with the speed, when you put a VFD in it, there's a big resistor, about this big. Take that out, you buy one of those $4 extended shaft, quarter-inch diameter jobs, and there's a gear that you would mount to that. It fits right in that hole where the old monster was, and then you have the rheostat, so you can adjust the speed.
Yeah, I have two, and I was wondering why there are two sections of the rheostat.
The rheostat has two sections because it's a compound wound motor. So one controls the field, and the other one controls the armature.
Okay. Well,
Energy comes from somewhere, we all know that.
yeah.
And it has to be transferred to something else, and it comes from somewhere.
That's right.
So where does it come from?
Good question. One of the devices that we had made, and that was Lithuania experiment. I went to Lithuania. There was 6 guys all together in that small lab. And we have made a successful manufacturing of the electricity from the ferrite, CRT, the TE2.
Right.
From behind you have something like a collar, double collar.
Right.
That's a ferrite, 2 halves. You have 2 winds on one half and 1 winding on the other one. That's all. We put 2 signal generators. Each signal generator was drawing about 5 watts from the grid, but the physical power that was delivered through the mismatch of the impedance, because the output of the generator is 50 ohms and the input is unknown because you have just the winding that you wind.
Yeah.
Okay, it was milliwatts. Now we were able to light up at first 60 watts, then 150 watts. Then we made something that is a U-shape, 1/2 of the wind with very thick one. And that give us an inframagnetic resonance, have a spin, and you're trying so you're creating the precision.
They're about balanced, and then as
There are fusing videos. Are they true? question mark
Yeah.
about the rotary disc with magnets and trying to create something that is a perpetual motion. See, that's what I'm dealing with. It's not really perpetual motion. You have the unity, okay, so the unity is 0 to 1. Then you have 1, which would be perpetual motion. Then over 1 you have over unity. What we're dealing with is over unity. When you're going to have the over unity, the very easy way, I give you $10, and now you have over unity because you didn't have the $10.
$10.
You know what I'm saying? So the whole story is just use less energy for work and create more energy, which never going to happen because it violates the second law of thermodynamics. What I believe is happening is that we're dealing with the conversion of the energy from one form to another, and that's how we get the energy. My understanding is that the sun energy, which is the heat, could be utilized, but we don't have to pay for it. The problem is that the devices that are able to utilize it only 17% efficient.
Very, very inefficient.
Yeah, very inefficient, 17%. What is the efficiency of gasoline engine? What we're dealing with is we say, well, we don't care that we have a 300% or 3,000% of efficiency. That is much more than one, right? Because we still don't have to pay for it. And that's just the whole story.
Makes sense.
We were talking about possibly either taking out the cylindrical part of original DC motor and mount the motor behind that, or if we decide that we use the shaft and
The U-joints?
the U-joints, or instead of the U-joints,
Constant velocity.
yeah, constant velocity, then the motor could be from behind. But then, if the motor is behind, is there any need for me just to eliminate the cylindrical part of the original DC motor? All I need is just a little shaft exposed just to have a coupling done, right?
Yeah. Gotta see what it takes to do that. You know, you need the motor. You need to take the motor apart and see what else has to be done to do that. For example, if the windings, it's an armature.
Right.
So, if the windings and the plate, the laminations, are so close to the bearing, now you got to start cutting into, you can almost cut the windings off, but now you got to worry about the balance of the darn thing, because you got to cut them off somewhat
Okay,
evenly.
well, my understanding is that the balance was there. When the winding is done, there is no control of the balance unless it's rebalanced afterwards.
Yeah.
So, if I take the whole rotor out, there is nothing that we will unbalance. It would be only the bare shaft.
If the
You understand what I'm saying?
I mean, you're going to press the shaft out of the laminations,
I'm gonna mill it out.
or mill the laminations off.
Yeah.
Yeah, I don't know. Some of those motors, the laminations are pressed on. So
Yeah.
if they press them on, you could
Yeah.
probably press them off.
Yeah. Just leave the shaft. Delete the shaft. When I leave the shaft, I have nothing in
You
it.
need-
It's
you
just
need
empty
to-
space.
Yeah, you got to narrow this thing up by at least 2
Yeah,
inches.
yeah.
And again, whatever casting influence you have in the back.
Well, in the back you have had the original mount for the motor generator. It is a little bit smaller
No, I don't have.
in the diameter.
No. The motor now is way small. Let's say the motor now is, I don't know, 11 inches.
Right,
The old motor's got to be 15 or 16 inches.
right.
Easy. Pretty big.
I see.
The motor generator, I've never seen, other than pictures, of a motor generator out. Because this had the works in a drawer.
Oh, I see. I see. Well, I have it. It's start from the rear of the machine and it goes approximately to this point. John?
You have a motor generator unit. On top of that is a little motor. That's the exciter for the generator portion. The AC motor, the synchronous motor, whatever you've got there, will start to turn when you apply the three-phase AC. That makes the generator turn. Also, that exciter turns. And the exciter develops the DC voltage, usually through the Ward-Mounted rheostat system, that generates the field voltage for the generator. to develop the motor voltage for the DC drive motor for the lathe. All right, if that's an exciter, it's a DC voltage that comes out of it. No voltage goes into it, it comes out. And that's connected to the field in the generator. It's probably a shunt line generator.
What is the advantage of having a servo drive versus the regular motor like you have? Spindle orientation?
Yeah, right, spindle orientation. I don't know, they're surely compact,
Right.
400, maybe they run at 400 hertz? Right.
All they do is just vary the frequency that is delivered to it, that's all.
So,
There was the old design back in 70s and 80s was a regular motor. Sometime that motor was called cell syn. On the same shot you had a taco reader.
the rod,
Yeah, the rod.
the control rod, you would buy that is called machine shafting. And
Machine shafting.
Yeah, and it comes with the groove already in it, which is the nice part.
And where these guys are located?
MSC, they're in Long Island.
Oh, really?
Yeah, the mail order. Just call them up. Very nice folks. I've been dealing with them for 15 years.
Oh, okay. I'm good.
So you have this cover here.
We have 3 switches.
3 switches, and I'll actually do. When I do this, you see the plungers move?
Yes, yes, I do.
Okay? So the only plunger that's moving right now would be the on-off switch.
Mm-hmm.
So whatever's moving, I think it's the bottom one, right?
Yes, that's the bottom
The
one.
bottom one, okay.
Yeah.
So, now the next switch, that switch that moves now, the bottom one and one of the other ones, I think maybe the top one moves?
Yes, yes, it is.
Okay. So, the way I have mine set up, that would be called forward.
Mm-hmm.
That would be the forward switch.
Mm-hmm.
And then, of course, that other one moves, now the middle one moves,
Right.
right?
Yes,
as well
yes,
as
it
the
is.
bottom. And that's the reverse switch.
I see.
So you program the VFD to recognize those signals from the wires. You know, there's no amperage. Goes first to the on-off, then to forward, then through forward to reverse. So it has to
I'm
have
serious.
obviously an on signal and a forward or reverse signal. When you get the VFD, you can kind of see how it goes.
Okay, bye-bye till tomorrow. That's enough. It's the first day with Monarch. The beauty of American engineering. The Rolls-Royce of lights.